For the polynomial function, use the remainder theorem and synthetic division to find f of k. Okay, so let's first use the synthetic division, and then we're going to use the remainder theorem. Okay, so we know the value of k is equal to 4i. So it's an imaginary number. Okay, and then we got to write down the leading coefficient. So keep in mind here that this is going to be 3x squared, and there's a missing term here, which is going to be plus 0x, and then plus 48. So the leading coefficient we have is 3, and then the next leading coefficient is 0, and then the next one is 48. Okay, so we're going to bring down the 3, and we get 3. Now what's 4i times 3? That's 12i. And 0 plus 12i is going to give us 12i. Okay, now what's 4 times 12? Well, 4 times 12 is 48. And I times I is I squared. Okay, so what does that mean? Well, what does 48i squared actually equal? Well, let's go ahead and multiply that. Remember that I squared is equal to -1. So if we take 48 and multiply that by -1, we're going to get -48. So 48 minus 48 is going to give us a remainder of 0. Okay, so now let's try the remainder theorem to see if we get the same result. So we're going to find f of 4i, and then we're going to plug it into the function. So this is 3 times 4i squared plus 48. Okay, so we have 3. Now remember here that this is 4i times 4i. Well, 4 times 4 is 16. I times I is I squared. So we're going to have 3 times 16i squared, and that's plus 48. Okay, now we're going to multiply 3 times 16i squared. 3 times 16i squared is going to be 48i squared plus 48. Now, what do we remember about I squared? Well, we're told that it's equal to what? -1. So this is 48 times -1 plus 48. So this is 48 times -1, which is -48, plus 48, gives us a remainder of 0, which checks with synthetic division. So therefore, our answer is 0.